Here we do some calculations having a mixture. Mixture is reacting with a particular compound. Okay, here a 2.1 gram of a mixture of sodium hydrogen carbonate and potassium chlorate need 100 milliliter of 0.1N acid, hydrochloric acid, for complete reaction. Okay, so we need to calculate the amount of residue. Residue means which is formed after the completion of the reaction in solid state. So that would be obtained on heating 2.2 grams of the same composition mixture. Same mixture means same composition in the mixture. అంటే NaHCO3 KClO3 percentages equal in the mixture. But ఇక్కడ given information is for 2.1 gram. We need to calculate it for 2.2 grams. Okay, 2.2 grams ఉన్న సేమ్ కాంపోజిషన్ ఉన్న మిక్చర్ని హీట్ చేస్తే వాట్ ఆర్ ద ప్రోడక్ట్స్ ఫార్మ్డ్ ఇన్ ద సాలిడ్ స్టేట్. ఆ సాలిడ్ స్టేట్లో ఫామ్ అయ్యే ప్రోడక్ట్స్ని మనం ఏమంటున్నామంటే రెసిడ్యూ అంటున్నాం. సో ఫస్ట్ గివెన్ ఇన్ఫర్మేషన్ 2.1 గ్రామ్. సో దాన్ని బేస్ చేసుకొని మనం 2.2 గ్రామ్స్ది ఫైండ్ అవుట్ చేయాలి. ఓకే, 2.1 గ్రామ్లో సోడియం హైడ్రోజన్ కార్బోనేట్ KClO3. Here both are present. Here the sodium hydrogen carbonate important one. Sodium hydrogen carbonate only reacts with the HCl, whereas KClO3 does not react with the HCl. Okay, ఇప్పుడు ఈ టూ మిక్చర్ ఆఫ్ 2.1 గ్రామ్లో సమ్ అమౌంట్ సోడియం హైడ్రోజన్ కార్బోనేట్ ఉంది, సమ్ అమౌంట్ KClO3 ఉంది. సో ఎంత అమౌంట్ ఆఫ్ సోడియం హైడ్రోజన్ కార్బోనేట్ ఉందో అది మొత్తం దేంతో రియాక్ట్ అవుతుంది, HClతో రియాక్ట్ అవుతుంది. సో వాట్ ఎవర్ ది అమౌంట్ ప్రజెంట్ in the mixture as sodium hydrogen carbonate is totally react with HCl. Okay, sodium hydrogen carbonate that is react with HCl. So with the help of the information of HCl is given. So with the help of HCl information we are able to calculate the amount of sodium hydrogen carbonate. Okay. Here only sodium hydrocarbonate reacts, so potassium chlorate does not react with the HCl. So sodium hydrocarbonate మాత్రమే HCl తో react అవుతుంది కాబట్టి here we can write milli equivalents. Okay, milli equivalents of NaHCO3 is exactly equal to the milli equivalents of HCl. That is N1 V1 is equal to N2 V2, and here we get what is the normality given 0.1. What is its value? This is 10 milli equivalents of HCl, nothing but which is equal to the milli equivalents of NaHCO3. So therefore we can write milli equivalents of NaHCO3 is equal to 10. But we need to get the weight of sodium hydrogen carbonate with the help of this information. So ఇక్కడ HCl part is completed. ఈ HCl part only దేనికంటే milli equivalents find out చేయడం. ఈ మిల్లీ ఈక్వలెన్స్ దేనికి ఈక్వల్ అంటే మిల్లీ ఈక్వలెన్స్ ఆఫ్ సోడియం హైడ్రోకార్బోనేట్ ఈజ్ ఈక్వల్. సో వాట్ ఇస్ ద మిల్లీ, యూ గోట్ ద మిల్లీ ఈక్వలెన్స్ ఆఫ్ సోడియం హైడ్రోకార్బోనేట్ ఈజ్ ఈక్వల్ టు 10. సో వాట్ ఇస్ ద ఫార్ములా ఫర్ మిల్లీ ఈక్వలెన్స్? జనరలీ నార్మాలిటీ ఇంటూ వాల్యూ. సో నార్మాలిటీ మీన్స్ weight of NaHCO3 by equivalent weight into 1000 by volume in milliliters into V. So all the calculation manaku vachindi, that is equal to 10. Okay, so weight of, we need to find weight of NaHCO3. by equivalent weight means equivalent weight we calculate with help of molecular weight by its charge. Molecular weight by its charge. So what is molecular weight? Its molecular weight will be treated as 84. Okay, so the equivalent weight means here what is the molecular weight by its valency. So as it is a salt, so Na plus HCO3 minus means its valency is 1. So what is its molecular weight? 23, 24, this is carbon 12, 48. So finally we will get 84 by its valency, nothing but charge is 1 into 1000 by what is the value given for HCl, nothing but so we need to calculate for NaHCO3, we will get cancel, that is equal to 10. And finally here we get weight of is equal to 0.84 grams. Now weight of NaHCO3 in 2.1 gram, 0.84 grams. So remaining weight in the KClO3. Okay. So therefore we can write the weight of KClO3 is equal to, that is 2.1 minus 0.84, that is approximately 1.26. Means weight of KClO3 1.26, weight of sodium hydrocarbonate is 0.84 in 2.1 gram. But here important is we need to calculate the problem in 2.2 grams. But given is it is same mixture. Same mixture means same composition and the percentages exactly same ఉన్నాయి. సో కాబట్టి ఈ 2.1 గ్రామ్తో వచ్చిన వాల్యూస్ బేస్ చేసుకొని మనం 2.2 గ్రామ్స్లో ఉన్న క్యాలిక్యులేషన్ చేయొచ్చు. So now we see that these are all for in 2.1 gram sample. 2.1 gram sample లో అది మనం ఫైనల్గా క్యాలిక్యులేట్ చేయాల్సింది 2.2 గ్రామ్కి క్యాలిక్యులేట్ చేయాలి. హ్యావింగ్ విత్ సేమ్ కాంపోజిషన్ ఇచ్చింది కాబట్టి దాన్ని బేస్ చేసుకొని చేయొచ్చు. ఫర్ ఎగ్జాంపుల్ in 2.1 gram of sample, in 2.1 gram of mixture, how much sodium hydrogen carbonate there? Sodium hydrogen carbonate is how many grams? 0.84 grams. So 2.1 gram contain this much. Then what about 2.2 grams mixture contain NaHCO3? How much? 2.1 gram lo 0.84 grams of sodium hydrogen carbonate unte. 2.2 lo how much? That is 2.84 by 2.1. Here approximately, so we will get 0.88 grams. 0.88 grams. So ఇది మనం పర్ఫెక్ట్ కాంపోజిషన్ కావాలి కాబట్టి 0.88 grams of compound is formed. Sodium hydrocarbonate అంటే ఇప్పుడు 0.88 grams. సో ఇదే మోడల్లో in 2.2 grams weight of KClO3 equals total weight 2.2. సో అది NaHCO3 0.88 వచ్చింది మనకి. So what is the amount of KClO3? Total amount 2.2. The weight of NaHCO3 0.88. Here we will get 1.32 gram. Okay. ఇక్కడ మన క్యాలిక్యులేషన్కి దిస్ ఈజ్ ద ఇనిషియల్ స్టేట్. 2.2 grams లో 2.2 గ్రాముల ఆఫ్ శాంపిల్లో 0.88 గ్రామ్ NaHCO3 ఉంది. 1.32 గ్రామ్ KClO3 ఉంది, పొటాషియం క్లోరైట్ ఉంది. ఇప్పుడు ఫైండ్ అవుట్ చేయాల్సింది ఏంటంటే ఆ 2.2 గ్రామ్స్లో we need to find the residue that would be obtained on heating. అంటే 0.88 గ్రామ్స్ సోడియం హైడ్రోజన్ కార్బోనేట్ని 1.32 గ్రామ్స్ ఆఫ్ పొటాషియం క్లోరైట్ని హీట్ చేస్తే వచ్చే రెసిడ్యూ ఏంటి? రెసిడ్యూ అంటే మనకి సాలిడ్ స్టేట్లో ఫామ్ అయ్యే ప్రోడక్ట్ ఎంత అది ఫైండ్ అవుట్ చేయాలి. ఇట్ ఈస్ బేస్డ్ ఆన్ ఇట్స్ రియాక్షన్స్. Now we see about this sodium hydrogen carbonate. On heating, so what is the sodium hydrogen carbonate reaction? It forms Na2CO3 plus H2O and CO2. So by substituting this, here how many moles? 2 moles. So here it is not a residue as a liquid state, it is not a residue as a gaseous state, so only it is treated as a residue. Okay, however the means 2 moles 1 mole means it is in terms of grams. So here 2 into 84 grams produce how much? 106 grams. Here we got only 0.88 grams. So then what about 0.88 grams can produce how much sodium carbonate? Here approximately the calculation we will get and finally we will get 0.55 gram. This is 0.55 gram of which compound? 0.55 grams of Na2CO3. This is the residue. Okay, అక్కడ ఫామ్ అయ్యే సాలిడ్ స్టేట్ కాంపౌండ్ Na2CO3 ఎంత ఫామ్ అయితే 0.88 గ్రామ్ నుంచి 0.55 గ్రామ్స్ ఫామ్ అయింది. నెక్స్ట్ ఇంకోటి మనకు అవసరం ఏంటి? KClO3. KClO3 HClతో రియాక్ట్ అవ్వదు, కానీ ఆన్ హీటింగ్ ఇట్ ఆల్సో డీకంపోజెస్. Now we see about residue formed by KClO3. KClO3 and this reaction will get KCl plus O2. Okay, so the 2 moles of potassium chloride gives 2 moles of KCl. So this is the gas, this is not treated as a residue, means we need to calculate the amount of KCl here. So KClO3 potassium 39, this is 35.5, this is 48, finally we will get 122.5 gram. Releases how much KCl? So this is potassium 39, 35 is 74.5. 2 into 74.5 grams of KCl is produced from this. This is according to the basic balanced equation. So then what about so what was the amount of KClO3? So the amount of KClO3 is actually there was 0.88 and there was 1.32 grams of KClO3 was there. 1.32 grams KClO3 produces how much residue? That is equal 1.32 here approximately we will get so here 22.5 is not there. 122.5. So approximately get 0.802 grams. Means so this is the amount of potassium chloride KClO3, potassium chloride KClO3 residue. So therefore the total residue means the first residue is formed by NaCO3 is Na2CO3. The second residue formed by KClO3 is KCl. So by adding these two we will get the final answer. Okay, so finally we will get 1.357 grams of total residue. Okay, here totally there is three steps are present in this problem. So first NaHCO3 KClO3 mixture, only this reacts. With the help of NaHCO3 reacting with HCl, we obtain the value of NaHCO3. So NaHCO3 base చేసుకొని KClO3 amount find out చేసాం in 2.1 gram. నెక్స్ట్ 2.1 గ్రామ్ బేస్ చేసుకొని 2.2 గ్రామ్స్లో ఫైండ్ అవుట్ చేస్తాం. ఆ 2.2 గ్రామ్స్లో వచ్చిన వాల్యూస్తోని ఈ రియాక్షన్లో సబ్స్టిట్యూట్ చేసి we will get the residue. Okay, so very important model. And obviously different problem. Here 1.67 grams of a mixture of aluminium and zinc was completely dissolved in an acid. So and they evolved 1.69 liters of H2 at STP. We need to calculate the weight of aluminium and zinc in 1.67 grams of that mixture. Here in the earlier problem there is also two compounds are there, that is sodium hydrogen carbonate and potassium chloride, in which only sodium hydrogen carbonate was reacted, whereas KClO3 potassium chloride was unreacted with that acid. But here these both are metals, aluminium, zinc, these two metals, generally metals compulsory reacts with acids and releases hydrogen gas. So this is the basic characteristic property of metals. Mainly all transition metals follow this rule. All metals reacts with acids, releases H2. Means aluminium reacts with acid, releasing H2. Zinc also reacting with acid, releasing H2. So it is given in terms of weight, not in terms of volume. So here we can write equivalence of aluminium, equivalence of zinc must be equal to the equivalence of HCl, or exactly equal to equivalent of the information given about H2. So equivalent means weight by equivalent weight. Just take weight is x gram by equivalent weight, that is 27. Molecular weight by what is the valence of aluminium? 3. Take the weight of zinc is y. Its equivalent weight means molecular atomic weight. But valence is zinc is always plus 2. That is 65 by 2. Here it is. What is the equivalent weight of H2? So what is the weight of H2? Here important one, it is given in terms of liters. 1.6 liter of H2 STP. So we know that at STP 22.4 liters equal to always molecular weight. So 22.4 liter hydrogen equals nothing but 2 gram, because any compound at STP having 22.4 liters possess equal to its molecular weight of mass. Then what about 1.69 liters is how much? that is 1.692. Here, so approximately we will get 0.150 grams. Okay. Now by writing this equivalent weight means weight by molecular weight, that is 0.150, and finally we will get and here the weight of hydrogen, we need to write weight by equivalent weight. So what is the weight? Weight is given in terms of 1.69 liter, that is TP. That liters we convert it into weight, that is 0.150. So its equivalent weight will be 1. It's 1 by 1. And here we get 99. And by taking LCM, here we will get into so that is equal to 32.5x plus 9y. And for this calculation, finally we will get 43.875. So it is an equation 1. Okay. So next see. And here we can write so according to the given problem, 1.67 grams of aluminum and zinc. So already we took the weight of aluminum x and weight of zinc is y. So x plus y is equal, we will get 1.67 grams. Okay, but this we are writing an equation that x plus y is equal to 1.67. Here we got in terms of another equation 32.5x plus 9y equal 43.875. So by solving this equation 1 and 2, so we do some changes in equation 2. So multiply it with 32.5x. Equal, by multiplying 1.67 into 32.5 we will get 54.275. Say it is equation 3. Okay. Now do the equation 3 minus 2. On equation 3 minus 2, this is 32.5x minus 32.5x get cancelled, and here we get 32.5y. Okay, we are writing total now. And it's 7.5. And here we get 23.5y is equal to, so exactly 10.4, and here y is equal to, this is 104 by 235, we will get 0.44 grams. So here y you got 0.44, so what is the y? the zinc is Y. Therefore, the amount of zinc is 0.44 grams. Then what about aluminium? So substitute in equation 2. Equation 2 lo substitute x plus y. X plus y means 0.44 equal to 1.67. So finally we will get that is approximately equal to 0.44 grams after the goal of 1.67. Here we will get approximately 1.23 gram. This is 1.23 gram is for what? Aluminium. Okay, so these are the calculation for the weight of aluminium, weight of zinc in the given sample. Here important one is just we are making the two equations with the help of given information, taking aluminium weight x, zinc weight y, x plus y 1.67 grams. And so these two are reacted with the acid. Both are given, they both release H2. So here we can write a step that is the equivalent weight of aluminium and zinc is equal to the equivalent weight of H2. Okay, here so sometimes we can equalize the milli equivalents, but here it is given only in terms of grams, not in terms of volumes. Okay, here volumes is given for hydrogen, here it is given in terms of STP. So we can convert it into grams. So that's why there is no problem. But we can't convert 1.67 grams into value because we don't know the separate weight of this one. Okay, finally we will get an equation in terms of xy. Means here we got two equations, x and y, between x and y. Okay, by solving this equation we will get the weight of zinc and weight of aluminium. Okay. Here see the third one. So a mixture of ferrous oxide and ferric oxide when heated in air to a constant weight gain 5%. Means here on heating the total mixture weight is increased to 5% in its weight. To find its composition means we need to find the percentages of this one and this one in the original mixture. So what is the amount of original mixture is not given. It is just given on after completion of the reaction there is a 5% increase takes place in it. Okay, here the reaction is just on heating reaction. So on heating FeO in air means in presence of generally it is oxidation reaction. It forms Fe2O3. So we must know this type of reaction. Okay, just for balancing purpose. Fe2O3 half O2. Next, what about Fe3O4? It also forms Fe2O3. So these are the fixed reactions. Okay, we need to remember these reactions. 3 2 8 9. Okay, these are the two reactions. Okay, take the first one, take the second one. And here the initial weight is not given, but final weight is initial weight plus 5% of it. This in terms of percentage kabatti we are taking the initial weight is 100. Okay, just let the FeO and Fe3O4. Okay, what is Fe and Fe3O4? Take the FeO is equal to x gram and Fe3O4 is y. And in terms of percentage, that's why we are taking x plus y is equal to 100. Okay, x plus y is equal to 100. This we are taking because it is given in terms of because in terms of a percentage. So now we calculate the the weights of these compounds, because due to the formation of these compounds only there is an increase in the weight takes place. Okay. Okay, according to this equation, first follow this equation. So according to this equation, here 2 moles of FeO forms 1 mole of Fe2O3. According to the first equation, we can write 2 moles of FeO produce how much Fe2O3? 1 mole of Fe2O3. So మనకి in terms of grams కావాలి కాబట్టి 2 moles means 2 into its molecular weight. So what's the molecular weight? Here molecular weight calculation is important. Here 56 32. So that approximately equal to 72. 2 into 72 grams. Okay, 56 there is 16. 72 gram produce how much? 1 mole of Fe2O3. 1 mole of Fe2O3 means 56 that is 48. This is approximately 160 grams of Fe2O3. Then how much FeO we taken? X gram. So X gram can produce how many grams? That is X into 160 by, so 2 into 144 grams. Okay, that low X into 160 X by 144 grams of Fe2O3 formed. Okay, so next, how much this 3 Fe2O3 will form? Now we will calculate this one with the help of second equation. With the help of second equation, 2 moles of Fe3O4 produce 3 moles of Fe2O3. 3 moles of Fe2O3. So Fe3O4. So what is the molecular weight of Fe3O4? Here we know the iron 56, 3 irons, and oxygen 64. So on this calculation we will get 232. Means 2 into 232 grams of Fe3O3 produce 3 into 160 grams of Fe2O3. Then what about, we took it as Y grams. So Y grams can produce how much? That is Y into 3 into 160 by 2 into 232. So here approximately general calculation we will get so don't do the total calculation. Here 240x by 242y by 232 grams. Means the amount of Fe2O3 formed here is 240y by 232 grams. అంటే ఇక్కడ మనం ఈ రెండు రియాక్షన్స్లో ఫామ్ అయిన ప్రోడక్ట్ వెయిట్ ఫైండ్ అవుట్ చేసినాం. అంటే స్టార్టింగ్ ఎంత తీసుకున్నాం? 100 గ్రామ్స్ అని తీసుకున్నాం. 100 గ్రామ్స్ అని తీసుకుంటే టోటల్ ఇనిషియల్ 100 గ్రామ్ ఎక్స్ ప్లస్ వై ఈక్వల్ 100 గ్రామ్స్. ఓకే, ఎక్స్ ఇది ఎక్స్ గ్రామ్, ఇది వై గ్రామ్ అని తీసుకుందాం. ఎక్స్ ప్లస్ వై గ్రామ్ తీసుకుంటే యాడ్ చేస్తే వీ సెడ్ ఇట్ యాజ్ 100. మీన్స్ ఎక్స్ ప్లస్ వై చేస్తే 100, కానీ ఎక్స్ గ్రామ్స్ నుంచి ఎంత Fe2O3 ఫామ్ అయింది? 160x by 144. అదే y గ్రామ్స్ నుంచి ఎంత ఫామ్ అయింది? 240y by 232 గ్రామ్స్. అంటే x, y ఏమో ఇనీషియల్ వెయిట్స్. ఈ 160x by 144, ఈ 242y by 232 ఆర్ ఆఫ్టర్ కంప్లీషన్ ఆఫ్ ద రియాక్షన్ their weights. Their weights means the weight of their products. And here a clue is given that 5% increase in its weight. అంటే స్టార్టింగ్లో 100 తీసుకుంటే ఫైనల్గా ఎంత అవుతుంది, 5% ఇంక్రీజ్ అవుతుందంటే 105 అవుతుంది. సో ఫైనల్గా ఉన్న కాంపౌండ్స్ ఏంటి మనకి Fe2O3. ఇక్కడ దిస్ మచ్ ఆఫ్ Fe2O3 ఫామ్ అయింది, ఇక్కడ దిస్ మచ్ ఆఫ్ Fe2O3 ఫామ్ అయింది. ఓకే, సో అంటే therefore now we can write 160x by 144, next 240y by 232 is equal to 105. So it is equation 2. Already we know the equation 1, that is x plus y is equal to 100 grams. So by solving these two equations, so just general solving at this time it is not possible, it is taken lot of time. Just by total calculation, by solving these two equations, we will get x equal to 20.25. 100 is put on the body, that is directly we can write as a percentage, that is 79.75. Means here FeO is 25%, Fe3O4 is 79.75%. Okay, this is somewhat a different problem compared to the earlier total problems. Okay, the practice for 2-3 times for this type of problems.